15. We're going to work on efficiently solving inequalities now. 51 is called lots of negatives, so we're going to be dealing with a lot of negative variables and negative numbers today. The first one, it gives us this inequality, negative x is greater than or equal to 4, negative 4. It says predict what you think the solutions on the number line would look like. So let's just talk about some numbers that would work as a solution here. Kellen?
1.
1 would work. All right. What happens when we have a negative in front of a variable? It switches the sign of whatever we put in. So if we say x equals 1, that would mean negative x would equal negative 1. We all okay with that? All right, so 1 would work because negative 1 is still greater than negative 4. All right, Kellen, you got another one?
0.
0, same thing. 0 doesn't really have a sign, so we can't flip it, so 0 would be greater than negative 4. Colin?
Negative 1.
Negative 1 would work because that would be 1, which is still greater than 4. Jared?
Negative 3.14.
Negative 3.14 or pi would work there too. What's the lowest number we could go? Chesney?
Number
Say it again.
4.
4. Right, if we put 4 in here, if we say x equals 4, then negative x would equal negative 4, which is greater than or equal to negative 4. So if we're talking about our solution to this one, this is the lowest number we could go. We would say x has to be less than negative 4. Well, okay there? All right. So now 2, we already kind of did some work on this. We just have to select all the values that are solutions to this one. Kellen, you got one?
Oh, I was just thinking on the previous one. Can we do any negative number because I'm going to be positive?
Yep.
So, like, you could go farther than negative 4? Okay.
All right. Jared, you got one here?
Well, not 4.001, negative 4.001.
This one? You're saying F? F would work, right? Negative 4.0001 would flip the sign, so it would be 4.001, which is greater. Chesney? C would work. 4, that would turn into negative 4, which is greater than or equal to 4. Georgia?
B.
B would work, right? We flip the sign there. Positive 3 is greater than negative 4. That works. Colin? A would work. Negative 3. We'd flip our sign here, so this 3 would turn to negative 3. And that's bigger than 4. And our last one, Chesney? D. Negative. All right, 2 negatives would flip it positive, so 4 is greater than 4. All right, so now it wants us to graph the solutions on the line. I think there's a number line on the next page here. All right, so do you guys remember from yesterday? I know we just talked about it. But we have x is greater than or equal to negative 4. Do we do closed circle or open circle when we have equal to? You guys remember, Brooklyn? Closed circle. And what does that closed circle mean?
It can be one. It can be that.
We include that number. So let's go number or label our number line here. So we're going to do a closed circle at 4. And we talked about our solution being less than. So our line or our arrow is going to go to the left. So again, that closed circle means we include 4. All right? All right, on to 15.2. We're going to do some work with tables. So we're just going to look here. Our inequality is x minus 3 is greater than negative 2. All right, so it gives us this table where here's x. It gives us our values for x here. And then the value it gives us here, so this first one is negative 4. It wants us to plug in to x minus 3. So we plug in negative 4 to x, it's negative 4 minus 3, which is negative 7. All right? So why don't you guys go through and try and complete that table. There's 5 empty blanks there if you guys want to try and fill that in. Done already?
Me too.
Hold your horses a little bit. Let everybody work. All right, Josh. -3 minus 3.
-6.
-6. All right.
Then -4. Then -3. Then -2. Then 0.
All right. Josh just decided to run the whole table.
Well, I thought you said.
He's going AWOL.
I thought
I thought we were supposed to.
Yeah.
All right. Well, maybe I want somebody else to answer some of these other ones.
I mean, it was
But Josh is just running the show now.
How about Josh
Okay.
can't answer any more questions?
Okay. I'm fine with that.
That old, yeah.
Maybe Josh answers all the questions for the rest of class.
Yeah, let's do that.
All right. So is everybody okay with our subtraction there? No questions on that? The table looks good to me. So now B says, for which values of x is it true that x minus 3 equal -2? So which value of x goes there? 1.
Am I answering all the questions?
No. I will call on you, Josh.
We should, and then if he gets one wrong, then we all get a free warm-up question, and then he doesn't.
Yeah.
Oh, it needs to be official petition signed for that.
Yeah.
Okay, let's petition.
Petition.
Who's starting it?
I would like to veto that petition.
All right. We can deal with these negotiations later.
For which value?
We got the class to tend to here. All right. Now, that was for x minus 3 equals -2. Now it's x minus 3 is greater than -2. So x, Chesney? All right, not quite 2. It's going to be greater than, less than, or equal to in the middle here. Jared, what do you think?
2, 3, and 4.
So how do we show that with an inequality?
Put a black dot on 2.
We're just going to use, you said 2, 3, and 4, right? So we're getting bigger. So we'd say x is greater than 1. Because here's 1, and -2 is not greater than -2. But everything to the right on 2 infinity is going to be a solution. So x is greater than 1. Here's our x values, right? Anything bigger than this one, anything to the right here, is going to be a solution here. We all okay with that? All right. Now we just did our solutions. Now we got to graph it. So we have greater than, open circle, close circle. Open, because we're not going to include -2. All right, so now we said x is greater than 1. So we go to 1, open circle, and everything greater than that, or to the right of that, will be our solution. That should be a 1. All right, open circle means we do not include 1. So 1.000001 would work, but not 1.
That was random. What zeros
I thought that was pretty relevant.
Well, I mean, like, you could have just said 0, 1.
Eh, I could have, but I didn't. All right. Now it gives us 2 times x is less than 6. So we're going to do the same thing. Predict which values of x will make the inequality 2x less than 6 true. So take your own guess here on this one. Take your own guess. And put something down. Just thinking. Georgia, what was your guess?
2.
What about 2? Just x equals 2 is going to work? Try and write an inequality here. So right, we did for this one. We said x greater than 1 after we actually solved it. Just take a guess at which inequality. Jonas?
X is less than 3.
Less than 3. Oh, we all got? Everybody had the exact same guess? All right, sweet.
I didn't.
That's the only guess.
All right. Now, again, we have another table here. 2x is just multiplying 2 times x. So here's our x values. Why don't we go through and finish this one? So -4 times 2, -8. Should all be able to handle these pretty easy. Oh, that is negative. All right, everybody good on the table here? All right. So now we did figure it out. We said anything less than 3 is going to be our solution. So what would that look like on my number line? Chesney?
Open circle, arrow upward.
Which way? Which way is our arrow gonna go? Autumn?
Towards the negative.
Towards the negative. We're gonna go less than, right? So any number less than? So open circle because we don't include 3. Because 3 times 2 would be 6, and 6 isn't less than 6. So we don't include 3. And then anything less than that would be good. So 2.999999999, Kellen,
Okay,
would work.
that was accurate.
All right. Now we have negative 2x is less than 6. So again, predict here. You guys can just make a prediction on your own and then we'll get going since we all seem to get it right. And then when you're done with your prediction, you can go on to complete that table there. Again, we're just taking negative 2x, negative 2 times x. All right, just remember on the table, negative times a negative is a positive. Negative times a positive is a negative, so just make sure we have our signs right here. All right, now what values of x would make this true, Georgia?
I put x is less than negative 3.
All right, how do you feel about x is less than negative 3? Colin, you got something different?
X is greater than negative 3.
What do we think about those two? We think it's x is less than negative 3. Couple of us? How about x is greater than negative 3? Couple of us. All right, well, let's look. Here's negative 3, and that's 6, so we know that one's not going to be true, right? Because 6 is not less than 6. What does if we go less than, negative 4 is less than negative 3. Does 8 make this true? Is 8 less than 6? No. How about 2? Is 4 less than 6? Yes. So it's going to be greater than. All right, so now what would our number line look like on this one? Veronica, what would our number line look like? Open circle on negative 3, right? Because we're not going to include negative 3. And then we're greater than, so we're going to go to the right. All right, then D asks us, how are the solutions to 2x is less than 6 different from the solutions negative 2x is less than 6? Think about that one for a little bit. How could we answer this question? How are these solutions different? Kellen, how are they different?
One is like, one has a greater than symbol and the other has a less than.
All right, so we could say different symbols. Chesney?
On the number line, on the first one, the arrow goes to the left, and the other one goes to the right.
Arrows in opposite directions. Brooklyn, do you have something different?
The opposites of each other?
Kind of. 3 and negative 3 would be opposites, but that doesn't mean the inequalities are necessarily opposites. Jonas?
Like one of them is 2x and the other one is negative 2x.
Yep, so one's a positive, one's a negative. All right, the other thing we can say is just that the solution here, 2x is less than 6, we can just write our solutions down. And this was x is greater than negative 3. So all those are ways that they're different right there. All right. All right, 15.3 gives us an inequality here. We're going to start adding equations to our inequalities a little bit. We should all be at least familiar with our equations by now. So this is negative 4x plus 5 is greater than or equal to 25. And now for A, we change our sign here. We go from greater than or equal to just to equal. And now it wants us to solve this. So what's my first step in solving here? Corbin?
Subtract 5 from both sides.
Subtract 5 from both sides. Now we have negative 4x equals 20. Next step. Colin?
Divide both sides by -4.
Divide both sides by -4. And x equals -5. All right, now it gives us a couple solutions here, possible solutions. It says in our inequality, we're back to our inequality now. Is it true when x equals 0? Josh says no. Evan says no. Most of us say no, right? -4 times 0 would be 0. Plus 5 is 5. 5 is not greater than or equal to 25. So that one's no. How about when x is 7? No. That wouldn't be true either. Right? -28 plus 5 is -23. That is not greater than or equal to 25. How about when x is -7?
Yes.
Yes. This would be yes, because now two negatives make a positive. 28 plus 5 is 33, which is bigger than 25. All right. So now we're going to graph our solution to the inequality this time. So now we got to figure out which numbers make this true. All right, which numbers make this true? What do you think, Chesney? -5 would make it true. And we said -7 would make it true. Kaylee?
-5 and down.
-5 and down would work. So if we put 0 here and we go, let's just go by 2's. So -5 would be right here. And then we go down. And we do have greater than or equal to, so we're going to use our closed circle here to include -5. Well, okay there? All right. 2 is the same kind of problem, just changes our equation up. Now we have 4/3 times x plus 3 is less than 23 over 3. So again, we go to an equal sign now when we're asked to solve. So why don't you guys try and solve that one and let me know what you come up with for x. Brooks, you got something?
Yeah, I got x equals 10/3.
10/3. I got something a little bit different than 10/3. Jared?
I got 5.
Just 5?
Yeah.
All right, well, let's go through this one. All right, what do we got to do first here?
Subtract.
We're going to subtract 3. And so if we put 3 as a fraction, what's 3 with a denominator of 3? 9/3. So we're going to subtract 9/3 from both sides here. Now we have 4/3 x equals 14 over 3. Now we have to get rid of 4/3 times x on both sides. So Colin,
Divide each side by 4/3.
we divide, which is the same as multiplying by the reciprocal, right? So we can just multiply by 3/4. All okay with that? All right, because those would cancel out. That'd just be 1, and now we're just left with x. So 14 times 3.
3.5 is the answer.
Eventually it will be. All right, we'd get 42 over 12. And like Josh said, that simplifies to 3.5 or 7 over 2. So our solution is x equals 7/2 or 3.5. Whichever you prefer there. All right, now B just asks us, is this inequality true when x equals 0?
No.
Josh says no. Chesney says no. We all think no. Well, what's 4/3 times 0? Plus 3? Is 3 less than 23 over 3?
Yeah.
So that would be true, right? 9/3 is less than 23/3. All right, now we got to graph our solution to this one. So we're going to start at 7/2. All right, this is where we're going to be. What kind of circle and which way is my arrow going to go? We just have less than, so what kind of circle? Open circle. All right, so we go to 7/2 here. Now, which way would this arrow go to make this inequality true? Not sure? All right, well, let's plug in 8/2 or 4. All right, it's 4/3 times 4. It's going to be 16/3. 16/3 plus 9/3. 25. Is 25/3 less than 23/3? No. So which way does the arrow have to go? Left. It's
A
got to
couple
go down.
easier ways to look at that too, guys. You can always plug in 0. What's 4/3 times 0? 0, right? So then you got is 3 less than that number. So yeah, so you know 0 is included. So 0 is always an easier one to check. Plus, if you have the variable on the left side, like Mr. Scott mentioned the other day, it's nice to have the variable always on the left. What symbol is that? Less than. Which way is less? Left. That's another way to look at it.
All right, so 3 asks us to solve the inequality. And now we have 3 times x plus 4 is greater than 17.4. And graph the solutions on the number line. So we're kind of skipping this step where we set it equal to. But this is still probably the easier way to figure out where we're going to start at on a number line. So we can set it equal and solve. And then, like Mr. Milbrand said, we can just plug in 0 to figure out which way our arrow would go. Those steps make sense? Kind of how we've been doing on 1 and 2 here, following that pattern. So why don't we try and solve this and figure out where our circle would be. It's our first step in solving this guy. We divide both sides by 3, right? And you can use calculators here to do 17.4 divided by 3. Chesney? 17.4 divided by 3 is 5.8. Now we have x plus 4 equals 5.8. Next step. Subtract 4 from both sides. X equals 1.8. All right, so we know our circle is going to be at 1.8. All right. Open circle, closed circle. Open. And now plug in 0 here. What's 0 plus 4? 4 times 3? Is 12 greater than 17.4? So which way does my arrow have to go? To the right, because 0 is not included. All right, so now that we kind of did that one together, why don't you guys try 4 on your own? See if you can come up with that solution and number line. Give you another 30 seconds or so to get where you can. Lost. All right, are we all done or getting close to done here? All right. So let's talk about solving this. We pretend this is an equal sign. It's our first step in solving here. We divide -3. Now we have x minus 4/3 equals -2. Now what do we have to do with this number, Colin? Add 4/3. And what do we get equal for x? Chesney? -2/3. All right, this would be -6/3. And if we add 4/3 to that, we'd end up at -2/3. You okay with that? All right, so now we have x equals -2/3. All right. So now we know our circle is going to be at -2/3. What kind of circle am I going to have? Closed, because we're going to include. All right, so we go to -2/3. Closed circle there. Let's plug in 0. What's 0 minus 4/3? -4/3 times 3. It's going to be 12/3. It'll be positive, right? So +4. +4 less than or equal to 6. Yep. So 0 is included, so we go to the right. We all okay with those steps? Just follow along. Number 2 here is going to be the best example when we're working on this kind of problems. We change our inequality sign to an equal sign. We solve for it, and then we check 0. And that tells us which way our arrow goes. All right, let's talk about the homework. 1 gives you an A and B, and it gives you 2 tables to fill in. We have x/2, so x divided by 2, and -x/2. So just complete those tables there, and then predict which values of x will make that true. So give me an inequality there that you think will work for each of these inequalities. All right. 2 says Diego is solving the inequality 100 minus 3x is greater than or equal to -50. He solves the equation and x equals 50. So what is the solution to the inequality now? All right, so all these are 50 because we got x equals 50. But what inequality sign is going to go there is what you got to figure out. We okay with that? All right. 3 says solve the inequality and graph that solution on a number line. So solve that one and draw me a number line there for number 3. 4 gives you a bunch of solutions here, and it says select all the values of x that make the inequality true. So you should have a good number there. All right. 5 and 6 on the back page. It's kind of what we were just working on. We're just drawing on number lines. It says draw the solution set for each of the following inequalities. So we have x is greater than 7 and x is greater than or equal to -4.2. So just draw those number lines. And then 6, it says the price of a pair of earrings is $22, but Priya buys them on sale for $13.20. This one's just asking by how much was the price discounted. So how much did you save there is what that one's asking. All right, how much did you save? B says what was the percentage of the discount? So how do we figure that out?
You take how much is off divided by the original price.
All right, so your answer on this one, whatever you get as an answer here, you're going to take that and you're going to divide it by the original price. So our original price was 22. And that'll be your answer, all right? All right, we got 7 minutes left to class if you guys want to get going on that homework.